picture. So there's two basic strategies here, right? Method of washers, which in this case is the method of disks, and the method of shells. So we can either think about chopping it up, chop, 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 into a bunch of disks, or we can think about it as a bunch of cylindrical shells. So I think cylindrical shells is probably the easier way to do this one. Oh, I have a really hard time illustrating it in the context of, well, anyway, nah. So what that means, this right here would just appear like that. Okay, fine. Yay. And then, of course, there's the rotation of this thing over to here. Let me get rid of this extra. So this is just what the solid looks like in the XY plane. And so the shell, sometimes books will draw this sort of ghostly thing that comes out of the page at you. I don't know if that helps or not, though. Really what matters is, so I'm trying to illustrate here, is a shell like this, right? So if you take this shell, and so what's the, excuse me, this distance here is x, right? So if I take this shell, right, and I lay it out like that, the question is, what's the little bit of volume for this slice? So this is what? You take this thing with radius x, right? And you lay it flat. How far was this distance? It's the circumference of taking the shell and laying it out flat, right? So this is 2 pi x. What's the height of the shell? Yeah.
Is it x or dx?
Well, dx would be the thickness right here, right?
So what, like x?
Let me draw in the picture. What is this?
8y.
That's exactly, this is y, which would be this up here. I should probably draw it in a different color. Right? So generically speaking, we've got 2 pi x y dx for a cylindrical shell that's revolved around the y-axis. Now, this assumes what? This assumes that there is no no, I'm sorry. I'm thinking of washers. That's it. What should x go from? This is for 0, less than or equal to x, less than or equal to? 6. 6. Yeah, b. But yeah, just criticism. Yes, my b is my 6. It's true. It's true. You got me. Now, what is y equal to, though? Y is equal to 2 pi x e to the minus x squared dx, right? Well, that is much better. See, e to the minus x squared I cannot integrate. But x e to the minus x squared, that's a u substitution. Just let u equal minus x squared, we're good to go. And that's how you would do both part A and B. Just put in specific B. Do you see? I need to make next step. So the volume will be the integral 2 pi x e to the minus x squared dx from 0 out to b. This same technique can be used to solve the torus problem, right? I was helping one of you earlier. One of the other problems in your homework is this. You've got a circle, and it rotates, right, like that. The big radius is h. The little radius is r, little r, right? The same technique can be used to set this up, right? You'd have the volume is the integral 2 pi x y dx. But you got to figure out what that y is, right? Actually, this one's a little bit trickier. Why is it not just y? It's actually going to be, why is it going to be 2y here? If I say that this point is x comma y, right? So here's, right, because it goes from y to minus, this point down here would also be x comma minus y, if it's that same y. And to find that y, you have to solve the equation for the circle that you're given, right? So it's like square root of stuff. What are the bounds going to be for this one? So this is h plus r, h minus r, right? And I think this is a trig substitution because this y is a square root of like a difference, or I forget if it's something minus x squared or if it's x squared minus something. I don't remember. But I think that's a trig substitution. You can't, it's not as nice as this one, which is just straight u, you know? And I think that's in a different section of the book altogether, right? That's in the trig substitution section.
Yeah.
Yeah.
That's
8.4. 8.4. What am I helping them with? Section 8.4, number
60.
Number 60. Okay, thanks. Nathaniel, right?
Yeah.
All right, so I've helped you guys with your homework all day. I'm allowed one example for fun, right? Right.
Can I ask one more quick question? Dang it. Like, real quick. You have to solve for the t on that to get like a definitive answer when you're sleeping.
We work it out. Yeah.
The bounds go from 0 to b.
Well, the A has B equals to 1, B has 4/3. But, you know, I think the right way to solve this problem is to solve it for B, find the formula in general, and then plug B equal to 1 in to get A, and plug B equals to 4/3 to get B. Then you have one integration to do and two evaluations as opposed to two integrals. It's up to you, though.
If I remember correctly, though, part B of this problem says that the volume equals 4/3, and I ask you to find.
Oh, then you have to solve it for B. So, yeah. So B is more interesting than I read it. Cool.
Yes.
So guys, something I wanted to share with you before I leave today is that if you have e to the, you know, let's say 3 plus I times t dt, what should the integral be? If there's any justice, what should it be? If I had asked you what the integral of e to the 3t dt was, what would you have told me? I hope you would have told me 1/3 e to the 3t, right? What would the natural analog to that be here? 1 over what? 3 plus I to the 3 plus I t. Yeah. That is in fact true. This is actually the integral of e to the 3t cosine t plus I e to the 3t sine t dt. This we can rewrite as 3 minus I over 10 e to the 3t cosine t plus I sine t plus a constant. And from this, I can read off that the integral of e to the 3t cosine t dt is equal to 3/10 e to the 3t cosine t. And guess what? While I'm at it, oh, I'm sorry, I missed one. Plus 3/10 e to the 3t sine t. And I also get that the integral of e to the 3t sine t dt is equal to minus 1/10 e to the 3t cosine t plus 1/10 e to the 3t sine t. Of course, plus c1 plus c2. How would you guys find these answers? What is your method for doing these integrals? Do you remember? We've talked about these. Do you remember what we did? How do you solve this integral? Usual calculus 2 style. You integrate by parts, right? You integrate by parts again, right? And then it like loops back and you do algebra, you solve for it. Which is easier? You're like, I don't understand what you just did, so the way I already know is easier. Fine. All I did was to convert this to a real expression, and I equated the real and imaginary parts of both sides. They have to be equal. They give you these two equations.
Is there a method, is that called something?
Complex variables, I suppose. Just another one of the multifaceted applications of the imaginary exponential to make your life easier if you're willing. But you don't have to. You can integrate by parts 2 times. It's all good. You know this. This is a very usual test question, by the way. Like if you look at all calculus 2 tests on integration, you will find exponential times sine probably 70% of the tests, I would guess. So I think when I did this in class before, it made it a little bit easier, was that I didn't have the 3 there. I had like e to the x cosine x or something. That makes it a little bit easier. Instead of getting a 10, you get a 2. Generically speaking, you get a squared plus b squared, which is easier for me to see. But anyway, shut up. I was going to spend longer on this, but you guys in your homework questions, man. No, I'm sorry. I seem to have gone over. I won't charge you, though.
We did start at the so.
Oh, we started late.